give a warm round of applause to our speaker of the night, Dr. Moiya McTier.
Thank you. Thanks, Amna. Thank you all. Ooh, I like this middle space. I might walk around a little bit. I am here to introduce you all to the Milky Way, which, in case you didn't know, is the big galaxy, the big collection of stars and gas and dust and dark matter that we all live in. We have lived in it our entire lives. Our sun formed in it. Our planet formed around our sun. So we are in and of the Milky Way. And the Milky Way is turning 3 in just a couple days, actually. And no, I'm not talking about the galaxy. The galaxy of the Milky Way is many billions of years old. I am, in fact, talking about my book, The Milky Way, an autobiography of our galaxy. And to celebrate, I have 3 copies here. Does anyone speak French? Or is anyone learning French? All right. Okay, cool. I have 2 English copies and 1 French copy. Because why not? So at the end, I'm going to give out some copies to people who ask questions that excite me. So think about some questions as I'm going through. The book came out about 3 years ago on August 16th. And so I would like you all to say hello to the Milky Way. The galaxy loved that. And then I would like you all to make a wish on the galaxy's behalf. You don't have to share it with anyone. Just take a moment right now. Make a wish for the galaxy's birthday. All right, let's get into it. I hope many of your wishes come true, if they were good. All right, so we're gonna talk about first how galaxies are born, because we're celebrating some birthdays here. Anyone really having a birthday today? You just lied. Okay, well, happy birthday sometimes. Okay, so galaxies are born in a universe. So we first have to talk about the birth and the evolution of the universe, starting all the way back about 14 billion years ago at the Big Bang. So the Big Bang is this moment of energy, this moment of expansion, where the universe started as this really tiny point, and then it expanded to things that could host galaxies. Things that large. And it took almost 400,000 years for the first atoms to form. That is how long it took the universe to cool down before even atoms could form. And then it had to cool down even more for stars to form. So we're waiting about 300 million years for stars, the first stars in the universe to form. And because galaxies are made of stars, you do kind of need those before galaxies can be born. This, I think, was supposed to be a video, this beautiful video of balls of light swirling together. But just imagine, if you will, some balls of light swirling together, because the way galaxies form is slowly, over time, through the collection of gas and dust, thanks to, can anyone name the force that makes that happen? Call it out. I'm hearing some gravity. Yes, it's gravity that is collecting all of this material and forming it into a blob that we call a galaxy. And that happens over many millions of years, but we can confidently say that our Milky Way existed 13 billion years ago. We know that because we can look at the stars, the oldest stars in our galaxy, and test how old they are. But this is an illustration from the book, from the Milky Way. It's the Milky Way being very sad because it's ripping apart nearby galaxies in order to feed off of its gas. And one thing that I imagined the galaxy thinking about humans was that, well, we aren't that important. In the grand universal scheme of things, we are not that important. But the Milky Way does love hearing our stories about it. Humans have been telling stories about space for thousands of years. We have evidence from Australia of indigenous people there doing really cool astronomical science where they're tracking the motion of stars and planets 45,000 years ago. So astronomy is the oldest science in the world, and us telling stories about the Milky Way made this personified version of our galaxy feel less alone and feel less destructive. So I'm going to talk to you about some creation myths. We talked about the science of how galaxies are born. What have our ancestors been thinking about it for thousands of years? And I want to start with my favorite story about the Milky Way's formation. It comes to us from the Khoisan people of southern Africa. And they have this story that starts with this little girl dancing around a bonfire at night, just having a great time, getting exhausted. as you do after a long night out. And the way the story goes is there's originally no light in the night sky. You have the sun during the day, and sometimes you have the moon, but there are no stars to give you any extra light. And so at the end of her night dancing, this young girl is lost, and she doesn't know how to get home, but she's so smart. She's clever. So she takes some of the embers from this fire, and she throws them up into the night sky, and that becomes the path of the Milky Way that she uses to light her way home. I love that story so much. It's stuck with me ever since I heard it a few years ago. But there are many other formation stories for the Milky Way. The reason we call it the Milky Way, does anyone know what culture that comes from? Greece. Yeah, we get the Milky Way from an ancient Greek myth about Hera, the goddess of marriage, who was tricked into nursing a baby Heracles. I don't know how much you know about Greek mythology. Heracles, the names might confuse you, but Heracles is not Hera's son. Heracles is Zeus's son from an affair. And so Hera, when she realizes that Zeus is nursing at her breast, she throws Heracles away, Hercules in the Roman, throws Heracles away, and there's a spurt of breast milk that becomes the Milky Way in our sky. So when you're looking up, just think of that. But there's so many other names that we've given it, and I want to play a little game with you. I have here 4 names for the Milky Way, but I made one of them up, and I want you to vote on which one is fake. So we're going to do this by hands and applause. Raise your hand if you think Backbone of the Night is a fake name. All right, okay, hands down. Raise your hand if you think Road to Xibalba is fake. Okay, all right, hands down. Raise your hand if you think Dragon's Breath Road is fake. Okay, that's winning so far. All right, hands down. Raise your hand if you think The Divine Way is fake. All right, okay, but I still think Dragon's Breath Road won that. Yeah, you're right. You're right. I just like dragons. But I do like to think of what that myth could be. In my mind, it's like a Chinese myth for how the Milky Way formed. But no, they call it the Silver Way or the River of Heaven, and it's much more poetic, I think. But the backbone of the night also comes to us from South African cultures. Makes a lot of sense, I think. When you look up at the Milky Way, it does kind of look like the spine of the night sky. The road to Xibalba comes to us from the Mayan people. There's a specific group of Maya called the Quiche, and they have a sun god named Kinnichahau. Every day, Kinnichahau walks across the sky from east to west to represent the sun going across the sky. And then in the nighttime, he turns into a jaguar, and he walks through this rift in the Milky Way, this dark, inky void that you can see down in the southern hemisphere, but we can't really see it here. So if you're trying to do some good astrotourism, go south. That's my tip for you. But Kinnichahau turns into a jaguar, and he walks into this rift to get to the underworld, which they called Xibalba. And then he walks across the underworld, facing all sorts of trials and tribulations, until he arrives again in the east and starts the whole cycle over again. So these are all names for the Milky Way that are all associated with their own stories. And I think it's so beautiful that humans have looked up at a very similar night sky, no matter what your perspective is. And we've thought about it as milk, as a flowing river, as this structural piece that upholds the night sky. And I think that's a really beautiful similarity that we see across cultures. We're going to go back into the science. One of the beautiful things that studying space for 10 years has given me is a really good mental map of the Milky Way. When I close my eyes, I can see it almost like the grid of Manhattan. And I want to impart some of that on you. This is an image of the Milky Way. Is this, show of hands, is this a real picture of the Milky Way? Raise your hand if you think it's not a real picture. Okay. Good. We have never taken a picture of the entire Milky Way. To do that would be like seeing your face, your entire face, without the help of a mirror or camera. We are in the Milky Way, and so until we send something out of it, we cannot turn it around to take a picture. But we have really good telescope missions that have given us a map of most of the stars. Gaia, the Gaia mission, has mapped over 1 billion stars around the Milky Way galaxy. So we have a good idea of how they're arranged. And this is a bird's eye view of the Milky Way, where you can see that kind of bright spot in the middle. We call that the bulge. And then you see the spiral arms coming out of either side of that. One of the arms is called Scutus Centaurus, or Scutum Centaurus, and the other is called the Perseus arm. And the sun is living right off of the Perseus arm. If you were to give like an alien from another galaxy our address, you would have to say that we're on Earth in the Sol system off of the Orion spur of the Perseus arm in the Milky Way galaxy, which is a lot to say. But that's how you have to make sacrifices in an intergalactic federation. We just have to do that. The Milky Way is about 100 light years across, and we, the sun, we are about halfway between the center and the edge. Although it's not really fair to call it an edge, because it kind of just fades into nothingness. There's no hard line. But we are about halfway between the middle and the edge, which means we are about 25,000 light years from the center of the galaxy. It's pretty far. The Milky Way is a large-ish galaxy. We'll get to some comparisons in a second. There are about 100 billion stars in the Milky Way, although it's hard to get an exact estimate, but that's the order of magnitude. And the total mass of the Milky Way is about 1 trillion times the mass of our sun. Most of the mass of the Milky Way, about 90%, is in dark matter. So it's not going to be stuff that you can see, but it is this big cloud of dark matter that exists around this part you can see. So let's look at the edge-on view for a second, because you can see that. You still see the bright bulge in the middle. Then you see the disk where the spiral arms are outside of the bulge. I like to call the disk the burbs of the Milky Way, because nothing happens here. All of the stars here are moving on very nice, easy circular orbits around the center of the galaxy. We might wiggle up and down a little bit, but nothing too extreme. Whereas in the center of the galaxy, in the Milky Way bulge, things are moving on wild-shaped orbits. They're making figure eights. They're doing little rosettes. Do you remember those spinner art toy things? I'm aging myself a little here, but that's what some stellar orbits look like in the center of the galaxy. They're beautiful and chaotic, and they run into each other, which is messy. The burbs. We're in the burbs. Outside of the flat disk of the Milky Way, you see this kind of cloud, this fuzzy halo. We call that the dark matter halo. That's 90% the mass of the Milky Way. That's also where you see these things called globular clusters. Those are the cores of old galaxies that the Milky Way has ripped apart and cannibalized. You're not excited enough about that. I think that's really cool. That's one of my favorite things about galaxies. So we can see evidence of how the Milky Way grew by studying those globular clusters. They're dense packets of maybe a few hundred or a few thousand stars, and they hold the chemical fingerprints of the galaxies that they formed in. And those chemical fingerprints are different from our Milky Way's chemical fingerprint. So it's we call this galactic archaeology, where you use chemistry of stars of different ages, and you track their motion to try and kind of backwards engineer what the Milky Way has gone through in its 13 billion years. So, don't discount the globular clusters, although most people are not going to talk about them because they're not in the disk. They're not in the burbs. That's not what most people hear about. And then in the center, I would be remiss not to bring up Sagittarius A star, the supermassive... Yeah. Do you study black holes or something? Oh, yes, Sagittarius rise up. Actually, you know what? Here. It's the supermassive black hole at the center of our galaxy. It weighs about 4 million times the mass of the sun. Does that sound like a lot? It does, doesn't it? And it is, compared to our sun, which is just 1 times the mass of the sun. But the largest black holes we've studied, the biggest supermassive, the most supermassive, they are up to 60 billion times the mass of the sun. They make Sagittarius A star look like a little wimp. And we call it Sagittarius A star because it, from our perspective, looks to be in the Sagittarius constellation, which means you cannot see it on your birthday. All right, so that's the anatomy of the Milky Way. Those are the different parts, and I'll probably be talking about the disk versus the bulge at different points. But one of the characteristic features of the Milky Way is those beautiful spiral arms. And so when I was writing the book, I had to include an explanation for why we have spiral arms in the first place. We used to think that because galaxies are rotating, all of the stars are orbiting around the center. We used to think that because galaxies are rotating, the spiral arms are just like the wound up streams of gas and stars. And that makes intuitive sense. But not when you consider how old the galaxy is. We saw that there are only two arms. The spirals don't wind very many times, but the galaxy has rotated at least 20 times in its almost 13 billion years. So we know that that's not the explanation. What it is really just a fancy cosmic traffic jam. Maybe this is also teaching you how traffic jams work, but when you have fluid motion, when you have many particles moving together like cars on a road or like stars orbiting around a galaxy, they're not all moving at the same speed. And if one of them slows down for whatever reason, that's going to create this domino effect in the cars behind it that have to slow down when they get to that same point. And so the traffic stays in one location even though cars move through the traffic. Does that make sense? Yeah. Spiral arms are doing the same thing, except it's stars that are getting caught in the traffic jam before they move out. And the traffic jam stays together through the force of gravity. That's what holds it together. And the reason it creates those spiral patterns is because of something called resonance. So if you remember back to a time when you were a kid or you experienced some whimsy more recently, you'll remember what it's like to be pushed on a swing. If someone pushes you at the wrong moment, in your swing, you're going to lose height, actually, instead of gaining it. So you have to push at just the right time. You have to be like in resonance with the person's natural swing. Some stars are getting caught up in resonance. They're being pushed on a swing as they go around the Milky Way by the bar in the center of the Milky Way. So if you think back to this center here with the bright part, it kind of looks like a bar. That bar is not quite solid, but the stars are really gravitationally bound, so it moves almost as a solid piece, and it pushes stars along if they have the right kind of orbit. Does that all make sense? Cool. Yes, so traffic jams, stars being pushed on a swing, and the way the Milky Way described it in the book is that it's like a very impressive sausage. An impressive but less gross sausage, because it's like the spiral arms are being held together in this casing by gravity, which is the intestine or something, I guess. Okay. There are different types of galaxies, and astronomers classify them based on their shapes. So our Milky Way is a classic spiral galaxy, a barred spiral, if you will. And there are other types. The most common other type is the elliptical. You can see here a graph, which we call the Hubble tuning fork, named after Edwin Hubble, who was an astronomer in the 1920s, the first to prove that the Milky Way is just one of many galaxies out in the universe. We learned that in 1920. Just 100 years of knowing there are galaxies. And he classified them based on their shape. So on the left side, he had the really round, kind of blobby ones. He called them ellipticals. And on the right side, he had the ones with more structure, which we call spirals. And he actually didn't believe that this is how they evolved, but he used confusing language because he called ellipticals early type galaxies and spirals late type galaxies, which does kind of give the impression that ellipticals will evolve into spirals over time, doesn't it? They don't. Don't follow that impression, because it's actually more like spiral galaxies that turn into elliptical galaxies when they merge together, just because it's really hard to maintain all of that beautiful spiral structure when you have the chaos of trillions of stars merging together. And then an interesting thing about spirals versus ellipticals is the way they hold their shape. So we just talked about how the spiral arms are maintained, and it's all about the stars going around in their orbits and getting pushed on the swing at the right time. Whereas ellipticals, they don't have spirals, they don't have that type of organization to hold themselves up. They are held up literally by chaos, by the chaotic motion of their stars moving in any sort of direction. You know, they're like the big boss. You don't want to fight an elliptical galaxy. They are older, they're more experienced, they usually look redder, they usually have older stars than the spirals, which are like young little inexperienced whippersnappers or something. That's what an elliptical galaxy would say. And then to talk about chemical evolution, you've probably heard the "we're all star" stuff. quote by Carl Sagan, which I do have later in the talk. But the way the Milky Way puts it is not that you're all star stuff, but that you are all a part of me. Everything you've ever touched is a part of me. Yes, even you, all of you, you vain, filthy animals. This is the first sentence I wrote when I wrote the book, and I think it's lived well. So to talk about chemistry, we have to talk about stars. That is the driving force of chemical evolution in any galaxy. And so I need to tell you about the different types of stars. Broadly speaking, there are, let's say, 7 different types of stars, and we classify them based on their mass, based on how much they weigh. So we have here from the left with the O stars, the most massive, down to the right with the M stars being the least massive. And I also have this fun little graph that shows you other information about them. So on the bottom of this graph, you see their masses. You see we're going from really massive on the left with 60 times the mass of the sun, although they can get up to about 200 times the mass of the sun. And then all the way down to the M stars, which are maybe like 10% the size of the sun. Okay, we're going to look at their lifespans here because the lifespan is inverse of the mass. It's the massive O stars that live very, very short lives. I'm talking like 10 million years. So short. That's a blip. That's a blink of an eye. But the M stars, they're living for trillions of years. We've actually never seen an M star go through all of its evolutionary phases because the universe just isn't old enough yet. And then on the other side, we have their temperatures. I want to give you a sense of their temperature, which does correlate with mass. So the O-type stars, they are up to 50,000 degrees in the scientist scale. And then M stars are much cooler, where they can only like 1,000 degrees or so. And our sun is right in the middle where the two lines cross about. We are an average star. Really, the only thing special about our sun is that there isn't another star orbiting it. Usually we find stars in pairs. About like 3/4 of stars exist in pairs. Our sun is completely average, except for the fact that it's single. That's okay. It's a valid lifestyle choice. It's what the sun wants. So all of the different types of stars have their own evolutionary paths. The low mass stars are going to have very different endings than the high mass stars. And this is a famous chart in astronomy. It's called the Hertzsprung-Russell diagram, after the two dudes who made it for the first time. And it has all of the potential fates of different types of stars on it if you know how to read it. So going on the bottom, it's temperature, but its high temperature goes to the left. Okay, and then luminosity on the vertical axis, that's how bright it is. So bright is up top and dim is down below. So as you get brighter and hotter, you're going up and to the left on this chart. Just a few things about chemical evolution for stars. The very first stars were made of pure hydrogen and helium, and they were huge, and they only lived for 1 million years. And they produced heavier elements in their cores, all the way up to iron. So we're talking like lithium and beryllium and other things up to iron. I'm not a chemist. I don't know. Astronomers literally call everything heavier than helium a metal. Like, that's how much we don't know about chemistry. We're just lumping them all together as metals. And so the earliest stars were made of just hydrogen and helium. The future generations of stars had more metals in them. A star's mass is going to determine how and when it dies. That's why I could show you the lifespan on the chart in the last slide. Low mass stars, the M-type stars, they are the most common. About 75% of, like 70 to 75% of stars are those very low mass types. And then it's only about 10 to 15% of stars that are like our sun. We actually have very few high mass stars, but those are the selfless ones that give back to the universe when they're done. So that's nice of them because they produce those heavier elements like the carbons and the nitrogens that we need to be people. And this is that Carl Sagan quote, "We are all made of star stuff." And this periodic table is my favorite periodic table because it shows you the cosmic origins of all of the different elements. You can see if you have good eyesight, the hydrogen and helium, they formed right after the Big Bang. And then the lighter elements, you get those forming in the cores of stars. By the time you get up to things like gold and silver and platinum, the heavy elements, you need to make those in extremely energetic, like cataclysmic events, like the merging of two black holes or something. And then there's like a whole bunch of unstable elements that we can only make in labs so far. But yeah, this is my favorite periodic table. I'm just gonna look at it. You can find it wherever you want. So go to NASA's website, they have it. Because we know that stars have this chemical evolution, that also should probably make us think that galaxies as a whole evolve chemically. And you can find interesting chemical trends throughout a galaxy. So this is actually a graph of the chemistry of different stars at different distances from the center of the galaxy. So the bottom axis, it tells you how far you are away from the center of the galaxy, your radius, your galactocentric radius. And then the vertical axis is telling you roughly how much iron you would expect to see in stars at that radius. Do you notice any interesting trends? I'm curious. Yes, as you move away from the center, the iron kind of goes up a little bit, it plateaus, and then it goes back down. So the further away you are from the galactic center, the fewer metals you're probably going to find in stars. Anything else? Yes, back here. Older stars have less iron in them. Yes, exactly, because those are stars that formed earlier on when there were fewer metals in the universe. Exactly, so you're spot on. The younger stars, they have a higher metallicity, they have more metals in them, using the astronomer's definition, and there are fewer metals near the edge of the galaxy. You got the observations I wanted. You're a very astute audience. I also want you to notice that there are not many stars near the edge of the galaxy. That orange line stops around 12, the 12 number, and it's because there aren't many stars of that age out near the edge of the galaxy. They tend to be in the center of the galaxy because they formed first, or they formed in other galaxies that got ripped apart, and then gravity kind of pulled them into the center of the Milky Way. You also, when I put the sun on this graph, you can see that it's higher than we expect it to be. The sun is about 4.5 billion years old, so technically should be in that green line, but it is a little bit higher up than we expect. And maybe our sun just has a youthful energy for a star. The sun would not get carded if it went out, I think is what I'm saying. It looks a lot younger than it is. It's also rotating a little bit faster than we think it should be. The sun is young and hot, guys. Good for the sun.
Hey friends, it's me. Sorry to interrupt this live show, but I have some messages for you. The first is a request. Please go and check out That's a Lot Show on Instagram, TikTok, and or YouTube. Episodes 3 and 4 come out the day this episode releases. Episodes 1 and 2 are already out, and we have 14 episodes total to share with you, released over the next month and change. So check it out, and I would be so grateful. Next, I want to say thank you to all of my patrons who support the show financially every month. I really would have a hard time making this show without you. You pay for editing fees and for site hosting fees and website hosting fees, so thank you so much. I want to give a special thank you and a huge shout out to my sun-like stars, Scott Reynolds, Tom T., Nicole Bartlett, and Ashley Shambo. I hope that you are having an especially golden day today. You too can join this group of people, hear your name on the show, make it onto my Patreon star chart, and get research notes for pretty much every episode for $5 a month at patreon.com/palebluepod. Hotter and brighter tiers like my sun-like stars get access to Pale Blue Pod at night, where I read bedtime stories in what I hope is a calm, soothing voice. Lately, I have been reading my PhD dissertation on the galactic habitable zone, which I do mention in this talk. Blue Giant stars at an even higher tier get to see videos of episode recordings, unedited. Yeah, That's right. So if you want to sign up for one of these tiers, you can do that at patreon.com/palebluepod. You can also sign up for an annual membership for any tier where you end up getting a 13% discount across the year. So check it out, patreon.com/palebluepod. Thank you in advance. My next message is a podcast recommendation. It's another show in the Multitude Collective, one of my personal favorites, actually, called Spirits, which is a history and comedy podcast focused on everything folklore, mythology, and the occult, told through the lens of feminism, queerness, and modern adulthood. Every week, mythology buff Julia and her childhood best friend Amanda get together to learn about a different story from mythology and folklore over drinks. They cover everything from the mythological origins of major franchises like Lord of the Rings and Wonder Woman and Pokemon, to modern urban legends, to a roundup of werewolf stories from around the world. They just did an episode about Merlin, yes, from Arthurian legend. And I don't know if you know this about me, but I used to be so obsessed with Arthurian legend that when I was a kid, that was my dream job, to be an Arthurian legend expert. So it was really cool to listen to this Merlin episode. Check it out. They have over 400 episodes that they've released over the last 7 years. Find them by searching for Spirits in your favorite podcast app or dive in at spiritspodcast.com. That link is also in the episode description. Okay, let's get back into this lecture. And if you ever find yourself in New York with some time to spare, check out Lectures on Tap. I have loved giving talks for them every month. The team behind it is incredible. These shows are so popular, they sell out in minutes, but Lectures on Tap also offers same-day tickets on their website, so definitely give it a look. All right, now let's get back into it.
My PhD research looked at where in the Milky Way galaxy we expect to find the conditions that are suitable for life. It was called the Galactic Habitable Zone. You may have heard of the Circumstellar Habitable Zone or the Goldilocks Zone. This is the distance from a star where the temperature is going to be right to have liquid water. If you're any closer, the water evaporates, any further away, and the water freezes. There's a similar concept for a galaxy, except it's not just based on distance, it's based on a whole bunch of other factors. I specifically looked at the motion of stars in the bulge, remember that chaotic central region of the Milky Way? I was simulating the motion of 1 billion stars in the Milky Way bulge, trying to see how often they have close encounters with each other, because I figured that bad things can happen through gravitational interactions if stars get too close to each other. And what I found was that there are way too many interactions there. About 80% of stars in the center of the galaxy can come within one solar system of each other every billion years. And I know 1 billion years sounds like a long time, but that is a lot of collisions in 1 billion years. So we would not expect to find many suitable, habitable planets in the center of the galaxy. But there are other factors that we have to consider. In the galactic habitable zone, you want there to be enough of those heavy elements that you can produce life. We are all made up of things much heavier than hydrogen and helium, so we need metals to survive. But we don't want to be too close to the stars. If we're too close to too many stars, then a supernova will probably go off, and there's going to be all sorts of dangerous radiation that could strip away our atmosphere or ruin our food chain, and we don't want any of that, right? Yeah, that's not good. We don't want any of that. So we need to be close to stars for the metals, but far away from stars for the radiation. We also need to have a stable orbit that isn't going to pass in and out of the spiral arms. You either want to always be ahead of the traffic jam or always behind it. And we are always ever so slightly behind the traffic jam. So we're lucky, but other stars aren't. And it also needs to be old enough. The star needs to be, at least several million years old, and then have stability for several billion years in order to produce life. We think that life didn't form on Earth until about 1 billion years after Earth formed. And that's very, very simple life. We didn't have anything recognizable as life until about 1 or 2 billion years ago. So this is a video that shows you what could happen if a star gets too close. So imagine those two disks are different solar systems coming together, and all of those tiny little dots are like planets and moons and other pebbles in the systems. If the stars get too close together, you can see how disruptive that is. It could potentially rip some planets away from their stars and just fling them out of their systems. Or it could interrupt the planet formation process altogether so that you never get planets in the first place. So that's bad. That is why the bulge is so bad and not in the galactic habitable zone. Those are the criteria that we look for. And when we look at the Milky Way, for the GHZ, it's here in this green ring that's about 20,000 to 30,000 light years away from the center of the galaxy. And it's symmetrical around the disk of the Milky Way. You know, there are burbs everywhere in the galaxy. And you also want the star to be similar to our sun's age. It should be between 4 and 8 billion years old, so that it has enough metals, but so that it has been around long enough for life to form. So when astronomers are out there trying to kind of optimize our search for life, these are the places we're going to look. We're going to look around stars that meet these criteria. And we also have to think about how the GHZ is going to change over time as chemistry evolves. As stars age, there will be more metals everywhere, so the galactic habitable zone will probably expand over the next couple billion years. I won't be here doing that research, but I hope that the astronomers a couple billion years from now read my paper on the galactic habitable zone and know what to look out for. So let's talk about the Milky Way's neighbors. It lives in a group of about 50 galaxies that are all gravitationally bound to each other. And the two closest to us are the Large and Small Magellanic Clouds. Has anyone here ever seen them? You can see them without binoculars or a telescope if you go close to the equator or down to the southern hemisphere. I saw them for the first time in Hawaii, and they're called the Magellanic Clouds after Ferdinand Magellan. And so there is this movement within some parts of the astronomy community to get their names changed because these galaxies, they're like about 1/10 the size of the Milky Way. These galaxies have been used by indigenous groups around the world, around the southern hemisphere, for navigation and for storytelling and for knowledge keeping. In Australia, they're this adorable old couple who fish out of the stream of the Milky Way, and other beings, other celestial beings, will help them out and bring them food. And that's just like a really nice lesson to teach. In parts of southern Africa, they would use these two galaxies as a way to predict drought, because when it was dry enough that sand got kicked up in the desert, you would only be able to see one of these galaxies and not the other. So they're useful for practical and cultural reasons. And so there is this movement to change them to something that's more respectful of their history. In the book, I call them Larry and Sammy for the Large and Small Magellanic Clouds, and the Milky Way does talk about them as if they are annoying neighbors. More Larry. The Milky Way has beef with Larry. The Milky Way would say that Sammy is probably the only galaxy it would consider a friend. And interactions with small satellite galaxies like this are quite common. Remember the globular clusters in our dark matter halo? Those are coming from old interactions with other galaxies from many billions of years ago. But the most important galaxy in our local group, at least from the Milky Way's perspective, is Andromeda, who it has been in love with for billions of years. It's been admiring Andromeda from afar. They actually send each other love notes in the form of hypervelocity stars that move so fast they reach the escape velocity of our galaxy. The Milky Way simps for Andromeda bad. So this is my favorite part of the book to write, and I wanted to add in that romance because, at least when I was in school, I was taught that there is a very, very high chance that in about 5 billion years, the Milky Way and Andromeda are going to merge. They will combine, and after many millions of years of dancing with each other and sharing material through gravitational interactions, they will form a new elliptical galaxy that astronomers have dubbed Milkomeda. That's its couple name. Except there was a paper just like in the last couple of months that kind of revisited those simulations and said now there's only a 50-50 chance that the Milky Way and Andromeda will get together. And I think that this is really nice will they, won't they fodder for the book. I really want them to get together. Like, what do you think? Do you want them to get together? I will say we won't die. Our sun will probably be fine. And one of the first calculations young astronomers do is figure out how many stars will collide between these galaxies that each host many billions, hundreds of billions of stars. And like 5 of them are gonna collide. What are the chances that our sun is one of the 5? No, so we'll be fine. Does that change your answer? How do you feel? We love a yearner. Yes, there needs to be more yearning in the universe. So do we want them together? Thank you. Okay, I'll put in a word with them. I'll whisper in Andromeda's ear, be like, come here. So I've told you about the science and the stories about the Milky Way. I do want to tell you a bit about my process for writing the book. The book is written from the Milky Way's perspective. It's an autobiography of the Milky Way. And this is how I wrote it. It's called method writing, if you will, because to get into the headspace of the galaxy, I had to be in complete and total isolation as much as possible. Highly recommend a writing fort, especially if you don't have a cat who will pounce on your head. So method writing is how I got it done. I really let the science guide a lot of things. When I was thinking about the personality for the Milky Way, which is why I wanted to hear your answers to that question, I was thinking about the fact that it's been kind of in isolation for billions of years. Most of the interactions it has with other galaxies, with its peers, are destructive, where it's like a battle, and the Milky Way ends up tearing that other galaxy apart and eating it for survival. Like, if I had to do that to everyone I ever met, I would feel bad. And I might mask that with a bit of a superiority complex. And so that's what the Milky Way does. It's very sassy, holier than thou to all of the humans it's addressing. The goals I had with writing this book were to make space, make the universe feel more relatable, feel more personable, if you will. Something that you could have a relationship with if you wanted to. And I think more of us would benefit from having a closer relationship to the wider universe around us. I wanted to show the evolution of our understanding of space, so not just, like the science results that we have now, but starting with the myths. So there are actually a lot more stories in the book than I shared with you tonight, because I think that's an important part of the journey of our understanding, and I wanted to expand our human perspectives as much as possible. Here's what the book is about. It was considered one of Publishers Weekly's best books of 2022. Thank you. Of the century. Yes. When I signed the deal for the book, they usually have this clause where it's like the publisher gets the rights in perpetuity throughout the universe. And because it's a book about the universe, I got them to take out that clause. So if I wanted to republish this book on Mars or something, I totally could. But it covers all of these things. In addition to what I talked about today, I go into more detail about black holes, about different myths, like the Mayan hero twins in Xibalba make an appearance. I go into quantum field theory. I learned quantum theory for this book, so you should read it just for that. Aliens, I talked about sci-fi. Einstein gets made fun of a lot. And my favorite review of the book, in case this influences your decision, said that this is the book for you if you've ever wanted to get domed by the universe. So, if that applies, go get it. But while I was writing this book, I spent 1.5 years writing it. I got galaxy brain. It really did shift my perspective. And one of the things it gave me is something, when astronauts come back from space, they talk about this thing called the overview effect, where looking down on Earth, where you can't see any of our borders or any of our human-made objects, it really makes you realize that all of the squabbles we have are so stupid and pointless, and they're just destructive for us. And so it really makes them think of themselves as Earthlings. And when I would, at the end of the day, leave my writing fort and stop pretending to be the galaxy, I'd really appreciate the fact that I am an Earthling and I am one part of this great, great machine, this great ecosystem called Earth, which includes all of you. And I felt disgustingly woo-hooey connected to everything around me. So the overview effect. Most of us aren't going to go to space, but we can try and steal little pieces of that for ourselves. Galaxy brain got me to realize that everything changes, maybe not on timescales that I would want it to, but the universe is so dynamic. Stars change and die over billions of years. The two major galaxies in our neighborhood are moving towards each other at something like 200,000 miles per second. Like they're going crazy fast towards each other. Everything that you don't like about right now is probably going to change if you give it enough time. So that was a good perspective shift for me. It's also really good for me to remember that I am only human. I have limits. There's a lot of stuff I can't do. There's a lot of stuff that I can do one day and then I can't do it the next. And pretending to be a galaxy, pretending to be something bigger and more powerful and smarter and like all of the good adjectives, more of that than myself, gave me some grace or like gave me some slack that I could then give to myself. So remember, we're only human. And finally, this is something I've been really working towards for my entire career, is the understanding that there's way more than just one way to know and study and see the universe. I have studied the universe through science and numbers and data. I have studied the universe through stories and myths and culture, and I will say that not like one of them isn't better than the other. They give me different perspectives. It's kind of like when you're looking out at the universe, there are so many different wavelengths of light, and you can look just in the visible part of the spectrum, you can look just in the radio part of the spectrum, but you're not going to understand the whole universe unless you see in all of the wavelengths of light. And so that's how I feel about learning about the universe. We have to learn about the universe in all of the wavelengths of light, including some that we can't even see. So, yay. I'm going to go through my shameless plugs. I host podcasts. So if you like my voice, you can hear it a lot more often. Exolore is about world building. Pale Blue Pod is about astronomy, but it's for people who are like kind of afraid of space. It's very cozy. Not as we speak, but after this, I'm going to go back to my writing for it, and I'm going to work on my next book, which is coming out next year. It's a history of science and creativity, written from the perspectives of the muses from Greek mythology. So you can see I'm following in the trend of not writing from my own point of view, which I think I'm going to make my thing. And then finally, I'm in my actor era, and with two of my best friends who are talented writers and comedians, I have made a micro-series. So if you want to follow along with it, you can follow That's a Lot Show, and it's 14 episodes. We're releasing a couple a week, and the bit, I guess, is that Sean, my co-host, and I are security guards at the last movie and film studio in the West. You can find it on socials. So we'll put it on TikTok and Instagram and YouTube. So follow That's a Lot. I think I watch the videos every night before I go to bed, because that is how funny I think they are, and I apparently don't care about my sleep hygiene. So these are my things. You can follow me at GoAstroMo, and you'll be kept apprised of all of this. So thank you.
Let's keep the applause going. Let's go. Yeah. We'll take 5 questions. So we'll start in this area. All right, let's go.
I actually have a couple questions, but I'll save the second if for some reason there's time at the end. So how did you get yourself into the mindset for the method writing, and how would you get yourself back out?
Yeah, it helped that I got this deal on March 10th, 2020. You know what happened. And so I had this thing from the world that let me sit in isolation for a long time and feel like the galaxy in that way. And really to get out of it, I just had to talk to someone. My cat.
Hi, thank you for speaking with us.
Thanks.
You mentioned at the beginning that the globular clusters are from like other galaxies that our galaxy is consumed. What's been the most interesting composite that you've read about as part of your studies that are like totally alien to our galaxy?
That's a great question. I'd say my favorite interaction that the Milky Way has had in its past is with, it was really early on. It was about maybe 5 billion years after the galaxy formed, so we're talking a long time ago. But it merged with another galaxy that was a similar size to it. Most of the galaxies that we interact with are much smaller than us. Merged with this bigger galaxy called Gaia Enceladus. And astronomers have located the remnants of Gaia Enceladus. We know where its globular clusters are, and we call them the Gaia sausage. which is just so disrespectful. And so I definitely incorporated it into the book. Do you speak French? Do you want to learn French? You choose. Yeah, take that. Okay, if someone who speaks French wants to ask a question, that'd be cool. Okay. Or learn it.
Well, we have one over here.
So first of all, I just want to say that your intelligence is so peak that you can also convey it to other people, and it's amazing to be in this room with you. You're awesome.
Thank you very much.
Okay, so you just talked about the Gaia sausage. All right, so travel time for a star's consumption after implosion or collision or whatever. What is the time between the consumption of that star and the star who's consuming it? How do you
yeah, so it's on the galaxy level, not the star level. And typically when do you speak French? Haha, you made me do a French laugh. So when galaxies merge, typically the stars themselves are not destroyed. Like I said, if Andromeda and Milky Way collide, most of the stars won't actually touch. So the stars just kind of become citizens of the new galaxy that forms through the merger, the new elliptical galaxy that forms. It's all of the gas that will be absorbed and combined, and you'll see this burst of new star formation that will light up the night sky, probably thousands of new stars being formed every year, and that's really what the difference will be.
Got another one here?
Hi. Thank you so much for tonight. I learned so much. Is there anything that befuddles you or still does while doing your research you wish you knew more on?
Selfishly, I am an exoplanets girly, and so I would love to answer the aliens question. I want to know where the life is. I do firmly believe it's out there. We have this rule of thumb in science where things either happen 0, 1, or infinity times. Right now, we know that life happens at least once. If we find it anywhere else, if we find it a second time, we'll know that life is everywhere. So I would really like to know that. If I were trying to be a good member of the astronomy community, I'm probably going to tackle the dark energy question. I think dark energy is 68% of the matter energy content of the universe. It's frankly embarrassing that we don't know what it is or how it works. So I would just like to close that gap a little bit.
Hi, thank you for the talk. It was very, very interesting. I'm curious about something you said early on about the black hole in the center of the galaxy, Sagittarius A or star something.
Yeah, A star. Yeah.
A star. So you said that there were stars within our galaxy that were 50 times the mass, or some much more massive than the black hole itself. So how is it possible that the galaxy, the gravitational force is such that they're orbiting around the black hole at the center rather than a more massive star within the galaxy?
Great question. So the black holes that are even more massive than Sagittarius A star, they are in different galaxies. Almost every galaxy that we've ever observed has a supermassive black hole at its center, and there are some exceptions, which is very exciting. But the really massive galaxies have really massive black holes. And we aren't totally sure why. We think that it probably grows through the merging of galaxies, and when galaxies merge and their gas mixes in the blender, then their black holes will also merge and just create a super massive black hole. But the one that I mentioned being about 60 billion times the mass of the sun, that's in a very distant galaxy.
Hi. My question is essentially regarding the more recent theory of the black hole cosmology, where our galaxy exists within a black hole, and the observable edge of our universe is actually just the event horizon of a black hole. So essentially there's another universe outside of what we can observe. I was wondering if you looked into that at all.
It's a really cool hypothesis. It is interesting, but it's something we can't really test right now, and I'm not sure how we would test it. But the idea is that we don't know exactly what set off the Big Bang. We don't know what existed before, and we don't know for sure what's going to exist after. And one theory that has been proposed is that the Big Bang was actually the formation of a black hole in a different universe, and that every time a black hole happens here in our universe, it's forming its own little universe. That'd be cool. I wouldn't mind it, but I don't have anything like definitively for or against it. I will say, I think it's another Sagan quote, extraordinary claims require extraordinary evidence, but I don't even know what type of evidence we could have to answer that question. So a strong perhaps. And it's nice to think about.
Right, I know we all have a lot of questions. I apologize, we don't have time for all of them, but luckily, Dr. McTier is amazing, so she's willing to give us more of her time. So after the lecture, you can always come in and ask your questions. My name is Amna. I was joined by Zach and Diana, my coworkers. This has been Lectures on Tap. Thank you so much, everyone, for joining. Thank you, Houston Hall. And of course, thank you, Dr. McTier. Have a lovely night, everyone.
Pale Blue Pod is hosted by me, Dr. Moiya McTier, aka the universe's bestie. I created the show with original co-host Corinne Caputo, a comedienne extraordinaire, and help from the Multitude Productions team. Our theme music is by Evan Johnston, and our cover art is by Shay McMullen, and our audio editing is handled by the incomparable Misha Stanton. I am Go Astro Mo everywhere online, and you can stay in touch with the show and the universe by following Pale Blue Pod on Instagram or checking out our website, palebluepod.com. We are a member of Multitude, an independent podcast collective and production studio. So if you like Pale Blue Pod, you will love the other shows that live at multitude.productions. And if you want a shout out on the show and research notes for every episode, you can join our community over at patreon.com/palebluepod for just about $1 per episode. Thank you so much for listening to Pale Blue Pod. I'll be back next week. Bye.